They said it couldn't be done, that we would never be able to look far enough, deep enough, or precisely enough to glimpse the beginnings of everything. But then came the James Webb Space Telescope, our time machine to the ancient universe. Floating 1,000,000 miles from Earth, balanced at the edge of gravitational equilibrium, this golden-eyed sentinel isn't just a telescope. It's a portal, peering into light that has traveled for over 13 billion years. This isn't science fiction. This is now. This is how humanity is watching the dawn of time unfold. To understand what the James Webb Space Telescope truly is, we have to first forget everything we think we know about telescopes. The Webb isn't a bigger version of Hubble. It's a different beast entirely, built not to look at stars in our galaxy, but to see the galaxies that existed before our galaxy was even born. This telescope sees in infrared, which is essential for one simple but profound reason. The universe is expanding, and the further back in time we look, the more stretched that ancient light becomes. What was once visible light from the first galaxies has been redshifted, stretched into long, cold infrared waves. To see the beginnings, we must see the cold echoes of ancient heat. So Webb was built to do just that. Its mirrors are plated in gold, not for decoration, but for efficiency. Gold reflects infrared light incredibly well. That massive, flower-like primary mirror is made of 18 hexagonal segments, precisely aligned, folding and unfolding like the petals of a celestial lotus. The entire telescope must stay cold, extraordinarily cold, just to function. At a chilling 233 degrees Celsius, its sun shield blocks the heat of the sun, earth, and moon, allowing Webb to detect the faintest whispers of heat from the deepest corners of the universe. But why look so far back? Because the light we see from distant galaxies today actually left those galaxies billions of years ago. So when we observe them, we're not seeing them as they are. We're seeing them as they were. With Webb, we are literally seeing the universe in its infancy. We are seeing galaxies as they were just a few 100 million years after the Big Bang. These are the building blocks of everything we know. Galaxies that existed when the cosmos was still assembling itself. The Webb allows us to trace the evolution of galaxies, from chaotic clouds of gas and dark matter to the elegant spirals and ellipticals we see in the present day. And it's already making discoveries that defy expectation. Webb has revealed galaxies that are larger, more mature, and more structured than scientists thought possible so soon after the Big Bang. These findings are shaking up our models of cosmic evolution. Were the first galaxies more efficient than we imagined? Was the early universe more dynamic? These questions are only just beginning to be asked. The answers may force us to rethink everything from dark matter to cosmic inflation. But Webb doesn't stop at galaxies. It's also peering into the hearts of stellar nurseries, massive clouds of gas where stars are born. Unlike optical telescopes, which struggle to see through the thick dust of these regions, Webb's infrared eyes cut through the veil, revealing the birth of stars and even the early formation of planetary systems. We can now witness disks of gas forming around new stars, potentially cradling the seeds of future Earth-like planets. It's like watching creation in real time. And speaking of planets, Webb is also rewriting the way we study worlds beyond our solar system. Using a technique called transmission spectroscopy, it examines the atmospheres of exoplanets as they pass in front of their stars. By analyzing how the starlight filters through a planet's atmosphere, Webb can detect the presence of gases like water vapor, carbon dioxide, and even signs of photochemical processes. This means we may be on the brink of identifying planets with conditions suitable for life, not just in theory, but in concrete, observable detail. Imagine that. Not just guessing whether alien worlds might be habitable, but knowing. Not just dreaming of distant Earths, but seeing their skies, their weather, maybe even their seasons. This is no longer imagination. This is measurement. And the implications are vast. With every scan of an exoplanet's atmosphere, we inch closer to answering one of humanity's oldest questions. Are we alone? All of this, remember, is being done from a telescope operating over 1,000,000 kilometers away, in the vacuum of space, shielded from the sun, folded like origami, and perfectly aligned to within nanometers. That level of engineering is staggering. Webb isn't just a triumph of astronomy. It's a triumph of human collaboration, vision, and patience. Over 30 years of development, thousands of scientists and engineers, countless delays, cost overruns, political hurdles. But it launched, and it unfolded, and it works. And now, it's giving us images that are nothing short of transcendent. Pillars of creation in new colors, deep fields packed with galaxies, some older than any star in our Milky Way, light bent by gravity itself, producing cosmic mirages. And each image carries with it not just beauty, but data. Raw, powerful, world-changing data. The kind of data that reshapes textbooks and redraws our understanding of the cosmos. But there's something deeper happening too, something less scientific and more philosophical. When we look at the images from Webb, we are not just looking at distant space. We are looking at ancient time. Every photon captured is a messenger from an age so far removed from our present that human civilization didn't yet exist. Not even Earth, not even the Sun. These are echoes of a universe before us. And somehow, we are here now, conscious, aware, building machines that can see that far, asking questions that stretch the imagination. The James Webb Space Telescope is more than a scientific tool. It is a mirror, showing us not only the origins of stars and galaxies, but also the miracle of our own curiosity. It reminds us that we are part of this story, a late chapter maybe, but no less meaningful. We are made of the same elements forged in ancient stars. We are the cosmos, wondering about itself. And the further Webb looks, the deeper our questions become. What came before the first galaxies? What dark forces shaped the cosmos? Are there universes beyond our own? As long as we keep asking, tools like Webb will keep answering, one photon at a time. If you've enjoyed this deep dive into the wonders of the James Webb Space Telescope and how it lets us see the very beginning of time, consider joining us on this cosmic journey. Subscribe to the channel, give the video a thumbs up, and share it with fellow stargazers. Because the more we look up, the more we understand who we are. The universe is still unfolding, and this is only the beginning.